So, welcome to this class. And this class is a continuation of our class in year 11. And just to recap, just a quick revision, we need to understand and be able to work with a shell model where we understood what's the meaning of shell, subshell, and orbit. We need to understand and recall the shapes of S, P, D, and F. We need to understand the rule of filling the shells and subshells. We need to recall the Aufbau principle, and we need to draw the electronic configuration of the first 36 elements in the periodic table. So to complete the electronic configuration or the electronic distribution of electrons in the shells and subshells and orbitals, we need to understand and we need to know three rules. And these are the Aufbau principle, Hund's rule, and Pauli's exclusion principle. We will come to know these one by one. In the class earlier, we said that imagine if you have a building, and in this building you have 7 floors. So in the first floor you have 1 flat, and the second floor you have 2 flats, and the third floor you have 3 flats, and the fourth you have 4 flats, and the fifth you have 4 flats, and the sixth you have 3 flats, and in the seventh you have 2 flats. So basically, these flats, they have names. So this is the name of this flat is S, S, P, S, P, D, etc. So the floors are basically, we call them energy levels. And then we have the subshells, and these are the S, or in case of the energy level number 1, or in case of energy level number 2, which is the S and P, these are subshells. And then we have the number 3, which is, it has 3 subshells, the S, P, and D, etc. And we said that each of these, they have basically a capacity. So the S capacity is 2 electrons, the P's capacity, maximum capacity, is 6 electrons, and the D's maximum capacity is 10 electrons, and the F's maximum capacity is 14 electrons. Okay, and as we said, when we look at the shapes of these subshells, we can recognize the orbitals. So here we have the S subshell, and it is basically, it has a spherical shape or circular shape. And then you have the p orbitals, and the B subshell, it has basically 3 orbitals, the X, the Y, and the Z. And the D orbital has 5 orbitals. So 1, 2, 3, 4, and 5. And as you can see here, the DXY, DYZ, and DXY, all of them are in between the axes, the X and Y, or the X and Y, or the Z and Y, etc. And then you've got the X, Y squared dash X squared dash Y squared, and you'll find them on the axis. And same applies to the Z squared. Don't forget that you need to learn and to remember the shapes of these orbitals. The d orbital, this is a demonstration of how the d orbital is being formed. So I will highly recommend you to look at this. So the next thing here is the definition of the orbit. And the definition of the orbit, as you said, like in case of B, in the case of p orbital, we have 3, in case of the p subshell, there are 3 orbitals. So that's the px, py, and bz. So the definition of the orbital is the is the region of space around the nucleus where an electron is likely to be found. So most likely you can find the electron in that region. So electronic configuration or electron configuration. The first principle that we need to understand here is something called Aufbau principle, like Actau principle. The pronunciation Aufbau principle. So basically this principle says that the electrons occupy the lowest energy orbital that can receive it. So the order of filling these subshells, it goes from the lowest energy to the highest energy. Lowest energy is this one, 1s, and then this, and then this, etc., etc. So if we want to make the order of the lowest energies, we can just follow the arrow. So if you follow the arrow, you will see that you have 1s, then you have 2s, then you have 2p, then you have 3s, then you have 3p, then you have 4s, then you have 3d, which is slightly higher than 4s, then you have 4p, then you have 5s, then you have 4d, 4p, 4s. So it is really important that you remember this diagram and be able to create the order of energy levels so that you can fill in the electrons. So the Aufbau principle, again, says that an electron occupies the lowest energy level before it goes to other energy levels. So if you have one electron, so this electron will go to the s, 1s. It will not jump and go to the 5s. But why? Because the 1s is the lowest, has the lowest energy, and therefore it will occupy it first. And then if you have extra electrons, they will go to 2s. If you have extra electrons, they'll not jump to 3s, they'll go to 2p. So it's 1s, 2s, 2p, 3s, 3p, 4s, etc., etc. Okay, so this is the first principle that we have to take in consideration. And this basically is the order of energy levels. So the 1s has a lower energy than 2s, has a lower energy than 2p, has a lower energy than 3s, than 3p, etc. What I want you to do now is to pause the video and to create the order of orbitals in relation to their energy, just like the one I showed you in the previous slide. So pause the video now, create that order on a piece of paper, and keep it beside you. Also, you can call this order energy ladder because you are going from the lowest to the highest. Okay, so again, the Aufbau principle means that electrons fill up the orbitals with increasing energy. So this diagram here is exactly as this diagram. Okay, so this and this are exactly the same. So what's the difference between them? The difference is that we have converted this diagram into boxes. So this is something we call it electron in boxes. So if you are asked to draw or to write the electron configuration in the form of electron in boxes, then you should use this. So as you can see here, the 1s, you convert it to one box. And then any s, you convert it to one box. And each box of these, wherever you see a box, each box is an orbit, and the orbit can take maximum of 2 electrons. So then you have 2p. So 2p maximum can take 6 electrons. So that's why you represent it in a form of a box divided into 3 rooms. So this is 2p. And then you have 3s, which is a box. And then you have the uh, the 3p, which is 3 boxes. Then you have the 4s, which is 1 box. Then you have 3d, which is 5 boxes, etc. Okay, so this representation is exactly as in here. So when you want to fill in electrons, as I said, the first thing you need to do is to create the order. And the order here is as follows. You don't need to write the sign of smaller than, so you don't need to write it. So you can just write 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4s, 5s, 4d, 5p, 6s. Okay, so after you write it down, then you start filling in the electrons. And as we said, the electrons will fill in the lowest energy levels first, and then they will go to the higher levels. So in case of hydrogen, we have 1 electron. So this electron will just occupy the 1s. In case of helium, we have 2 electrons. So these 2 electrons, they will occupy the s. In case of lithium, we have 3 electrons. So 2 electrons will go in here. 2 electrons will go in here, and the remaining will go here. So basically 1s2, 2s1, 1s2, 2s1. And then beryllium has 4 electrons. So 2 will go to the s, and 2 will go to the 2s. So if we see the order again, so it is 1s2, 2s2. And then if we go to neon, neon has 10 electrons. So 2 electrons will go in here, 2 electrons will go in here, and 6 electrons will go in here. So 2 and 2 is 4, plus 6, that's 10. So this basically tells us about how to use the Aufbau principle. Now, the Aufbau principle is not the only principle that we have to take in consideration while we are doing the electronic configuration. So there are other 2 principles, but for now, it is good to understand that whenever you want to do the electronic configuration, you always start from the lowest energy, and then you start filling the electrons into the shells accordingly. Here we have an example, electronic configuration of chlorine. So I would like you to pause the video and to try with this by yourself. Okay, so we have 17 electrons here. So 17 electrons means that they will be filled into this order. 2, 2, 6, 2, that's 12, and then 5 in here. So 2, 2, 6, 2, and 5. The orbital, the subshell, it can take less than the maximum capacity. So if the maximum capacity of something is, let's say, 6, in case of p orbital, it can take 5, it can take 4 or 3, but it cannot take 7 or 8. So this is how we can apply the first rule in filling in the electrons um, in relation to the Aufbau principle. Now, these questions, we will answer them in the class, but also you should try with these, try before you go to the next slide, because the answers are available in the next slide. So try with these before you go to the next slide and check your understanding. Um, Here again, you should try this, click on it, and test your knowledge. At the end of the test, there'll be a score, and this will tell you how much you scored and the wrong answers that that you have done in the test, and their correct the correct answer that should have been completed. Okay, the next concept here we need to understand is something called electron spin. And the electron spin is basically the easiest way to look at it is that the electron is a charged particle, and this charged particle it can basically create magnetic field around it as it spins. And this, since basically it creates a magnetic field, it's like a magnet. It has a direction, so it can be pointing up or it can be pointing down. So Pauli exclusion principle, and this is the second principle that we have to take in consideration while we are filling in the electrons. It says that two electrons in the same orbital must have different spins. So if one of the electrons in the same orbital, and we said the orbital is the box, so in case of B orbital, we have three boxes. In case of uh, the P subshell, we have three boxes. Each of these boxes is representing an orbital. So Pauli exclusion principle says that in each of these orbital, each of the electrons must have a different spin. So what does that mean? So if one of the electron has a spin up, the other one must have a spin down. And the way you represent this is by drawing an arrow pointing upwards and an arrow pointing downward. Okay? So this is basically the Pauli exclusion principle. So just to recap, we spoke about Hund's rule, and we say in case of Hund's rule, apologies, in case of Aufbau principle, we need to start filling the electrons at the lowest energy levels. And then in case of the Pauli exclusion principle, we said that no two electrons in the same orbital will have the same spin. So if the electron is spinning upward, then the other electron must be spinning downward. Okay. The final rule that we take in consideration is the follows, is Hund's rule. And Hund's rule basically, it says when electrons are placed in a set of orbitals with equal energy, they separate out to maximize the number of unpaired electrons. So what does that mean? It means that, let's imagine we have four electrons, and these four electrons, we want to fill them in p orbital. So how do we fill these four electrons? So should we basically do it this way? So here, this is the p subshell, and we have four electrons we want to fill them in. So how should we fill them in? Should we fill them like this? 1, 2, 3, 4. And as you can see here, I have applied the Pauli exclusion principle. So there is an electron pointing up and pointing down. I cannot put two electrons in one orbital, both of them pointing up, or both of them pointing down. Okay, so we can't do this, and we can't do this. Okay, so in relation to the Hund's rule, how can I fill the electrons in? What should I do? It's basically telling you that if you have, let's say, four electrons and you want to distribute them in p orbital, you have basically spread the energy first. So you start distributing the electrons as unpaired electrons. So you have 4, so then you go 1, 2, 3, 4. Fine. So you don't do it this way is wrong. You do it this way. So these are the 3 rules that we have to take in consideration when we do the electron configuration. First one is the Aufbau principle, and this says that you have to fill in the electrons starting from the lowest energy level going up to the higher energy levels. And then the other one is Pauli exclusion principle, where it says that there are no 2 electrons in the same orbital, with the same spin. That means spin up or spin down. And finally, the Hans rule, where basically you have to distribute the electrons as unpaired electrons and then pair them up. So if you have 5 electrons, imagine you are doing d orbital. So you have, and we have 7 electrons. 7 electrons. So you go 1, 2, 3, 4, 5, 6, 7. Okay, so you start distributing the electrons as unpaired electrons, and then you pair them up at the end for the remaining number. Basically here, as you can see, you have an exercise with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. What I'd like you to do is take the names of these elements and then try to do the electron configuration of these elements without looking at this, and then compare your answer with this answer. Okay, so there are a couple of exceptions here that we need to look at. And this is what we will do in the extra class that we will be doing together, as well as taking some questions from the past papers. I hope that was beneficial, and I'll see you next class.